Good pre-afternoon, everyone. Welcome to our Cosmic Conversations here on the Morrison Planetarium Facebook page. My name is Josh Roberts. I'm part of the Morrison Planetarium team, and I'm honored to be joined here by Seth Shostak of the SETI Institute. How are you doing, Seth?
Well, reasonably well, sheltering in place in the South Bay.
I suppose there are worse places to be hanging out, submarines, Antarctica.
Central Greenland, but at least you wouldn't get the virus.
That's wonderful to hear. So, Seth, you are an expert in SETI. Can you tell us a little bit about that?
Yeah, sure. SETI is just our attempt to find not just life in space, but, clever life in space, like the residents of, San Mateo or something. And the way we do that is we try and eavesdrop on radio signals. That's the number one approach. But there are other experiments, and I'm going to talk a little bit today about some yet other approaches. But, we also look for laser flashes and stuff like that.
I suppose somebody blinking a laser pointer at us from the cosmic deep would be a pretty good sign that somebody out there is trying to bother us.
Well, they're trying to get in touch, and think about it. I mean, if you went out tonight and you have a clear sky, which probably doesn't apply to anybody who's tuned into this, but if you did and you saw maybe a 1,000th of a second red flash, by some star out there or not even near a star, but didn't see it again, what would you do about that? You might tell your neighbor or your dog or something, but you'd probably forget about it unless you saw it again. Even if the aliens were just flashing our planet, once every 2 weeks, nobody would ever have noticed.
That's a unfortunate point. So unless aliens are communicating in really the right way, it's likely to just go unnoticed.
There is that very possibility that it doesn't keep me up at night, but I have to say it's it's certainly a possibility.
Well, if it kept you up at night, it might increase the chance we'd see it. So I believe you've got some PowerPoint you wanted to share with us, right, Seth?
Yeah, I do. And I'll try and do that. This may take only 20 or 30 minutes for me to get it to go right, but hang on.
Wonderful. Even after all this shelter in place, we're all still learning about the wonderful challenges of technological hurdles. Well, while Seth is getting that sorted out, we have a cool opportunity to really dive deep on some of these questions with a real expert. So if any of you folks have questions or ideas you want to share with us, use the comments section on the Morrison Planetarium Facebook page. And if you're watching this on SETI's YouTube, we have a little bit of a harder time seeing it. So if you can join us on the Facebook page, we would appreciate that as well, especially if you want to have that two-way communication. With that, though, I think Seth is back. We are getting the PowerPoint straightened out.
Yeah, I'm not getting it. So, okay, share screen. Let's see if I can share this screen. Here we go. Can anybody see that?
Not quite yet.
Really? Well, that's too bad. Hold on. Okay, so I'll do this. You would think that this, after 16 hours of rehearsal, this would work.
You do credit us too much, sir.
Here we go. Okay, can you see that?
We can indeed.
All right, what about that?
Ooh, looks like a corner of a gray's head.
Yes, well, that's right. Actually, this particular alien was sent to me many years ago by the manufacturer, who it turns out was an Earthling. And I think that they thought that maybe we could help them sell these alien heads. We have that sitting on the desk of one of my colleagues. And yeah. Anyhow, if you can see this and if you can hear me, raise your hand. No, don't raise your hand because I won't be able to hear you. Josh, tell me, is it all go?
We can see it. I think we're good to go.
All right, then listen. The way this is going to work is I'm going to prattle at the audience, both of you guys. I'm going to prattle at the audience for a number of minutes here, talking about another way to maybe find the aliens. And after that, we're going to go into space with Josh, who's going to use the Morrison Planetarium's high-tech ability to do that, talk a little bit more about this idea, and then we go to Q&A, because that'll be the interesting part of this talk for me and maybe for you as well. Anyhow, all right, so how do we find ET? We've already talked about how that's done in the conventional way. We just use these big antennas. This is the Allen Telescope Array, and although there's a dime in this photo for scale, you may not see it. This array is about 300 miles north of San Francisco in the Cascade Mountains, and each of these antennas is about 20 feet in diameter, the dish. Wow. There are 42 of them. So anyhow, but we use these things, and there are other telescopes, radio telescopes around the world where we're also looking for signals. Now, we've been doing that for a long time, and we haven't heard anything. So why is that? I mean, is it total incompetence? It's not. The people who do this are very clever. Most of them are in the Bay Area, actually. But the one difficulty you could say is that, all right, maybe the aliens are not out there. That's possible. Maybe there just aren't any aliens. But I doubt that you're listening to this if you thought that. I mean, I certainly don't think. And when people ask me, why do you think there are aliens out there? It isn't because it's part of the job description for me. It's because, we found planets around other stars in the last, 25 years. And, the number of planets in the Milky Way, just our galaxy, is, roughly 1 trillion with a T, trillion. That's a lot of planets. Most of them are probably
planets.
Most of them are probably kind of worthless for life, like Neptune or Uranus or whatever, Pluto. But some of them have to be good enough for life. I mean, you can't say Earth is the only planet that's the good one out of them all. It doesn't make sense. It's like saying that the first lottery ticket you buy is the only winner. It might be, but it's probably not going to be the case. Another possibility: the aliens are just hiding because they don't want to make their presence known. Because who knows? I mean, if you make your presence known, somebody will come after you. The usual metaphor for that is
Empire.
Yeah, well, Galactic Empire. I don't know if there's a Galactic Empire. If there is, I want to meet some of the members and see if they have wrinkly faces and stuff like that. But, I don't know about an empire, but maybe. And in any case, the universe is very old compared to the Earth, 3 times as old. So if there are, societies out there, some of them will be much older than ours. So they might be very advanced. And so, maybe the unwritten rule is lay low. Don't make a lot of noise. The other very, very common answer to why we haven't found the aliens is we simply haven't done enough of the experiment. I personally think that's the right answer, and that's what people are doing now. But there's another argument that sort of motivates these comments of mine, which won't go more than 6.5 hours. And that is the experiments are simply not sensitive enough. For the propeller heads in the audience, this is a typical sensitivity of radio SETI experiments. So, that means, those numbers at the top, 10 to the minus 23, 10 to the minus 25 watts in 1 hertz channel. What that translates to is that if you want to hear the aliens, and let's say they're 300 light years away, that's just a random number, but within 300 light years, there are like 1 million star systems. So maybe there's at least one society. They need to have that transmitter has to be, 10 to the 13, 10 to the 15 watts if they're going to broadcast in all directions.
It's a huge amount of power.
It is. 10 to the 13 watts is everything that humanity uses, all the light bulbs, your car, the planes, the trains, the buses, all energy usage is like 10 to the 13th when you add it all up, 10 trillion watts. Well, this is the kind of sensitivity that all SETI experiments have. That's just dictated by our level of technology. So that's a big, a big PG&E bill, right?
Sure.
If you have to pay for 1 trillion watts, what did I work that out? That's like 1 trillion watts. Well, it's on the order of $100 billion per hour. Wow. If you're buying it from PG&E, maybe there are, inexpensive alternatives, but still, that might be expensive even for aliens. So maybe they beam a signal toward us, and then they wouldn't have the big power bill. But for them to beam a signal to us, they should know about us. Mm-hmm. And it's my contention here, Josh, that they simply don't know about us because we've only made the presence of Homo sapiens apparent in the last, 70 years. Here you see Howdy Doody and Buffalo Bob. Our TV, our radar, our FM radio, all signals that go out into space, they only began after the Second World War. So they're not very far into space. Let's say 70 light years. If the aliens are more than 35 light years out, there simply hasn't been enough time for these signals to get to them, for them to decide that they just don't like this show and send their criticisms back to us at the speed of light. It's very unlikely that anybody has had time enough to do that. Our presence is simply unknown to the galaxy. And you might consider that fact the next time your next door neighbor says that he's been abducted for breeding experiments by aliens who are visiting Earth, because they don't know we're here. So why did they come? I mean, well, all right, just another couple of slides here. So what I'm going to suggest here is that rather than looking for signals, because, you know, either the aliens broadcast in all directions, in which case the power bill is really stunning, or they deliberately target our solar system because they know we're here, which seems unlikely. But if you look for physical manifestations, if you look for something the aliens have built, and by the way, this is not a real photo for the four of you who thought it was.
Pretty exciting if it was.
Yeah, this would be nifty. Maybe this is our future. This is what San Francisco will look like, 15 centuries from now. But anyhow, you look for something that they built, because there are big advantages if you look for that. I mean, there are aliens out there that are maybe billions of years more advanced than we are. Mm-hmm. So maybe they built something. I mean, who knows? Well, the big advantage of looking for these things is, one, they don't need to have that big power bill. Already said that. Also removes this problem, because our SETI experiments are looking at, one spot on the sky for essentially minutes, not much more than that, because there's so many frequencies to check out. And so you have to hope that the aliens are broadcasting something that's getting to you during the few minutes that you're listening. And so that's a big problem, because maybe they're not. Maybe they broadcast something to us, 100,000 years or 100 million years ago. So it gets rid of that problem. They don't have to have signals reaching you at the time you look. There's this problem that it solves, that maybe you shouldn't say anything because it's dangerous. This is, I think everybody recognizes.
Steven's a big proponent of not making ourselves too obvious to any aliens that might be out there.
Yeah, he certainly said that, and it's a little unclear whether he meant it. And the other big advantage is, artifacts can hang around for a long time, even when the people who built them, or the aliens who built them, are long gone. If you want to find the pharaohs of Egypt, you could go to Egypt, but you won't find them. Well, you find them in the museum, but they're all sort of stiff and dusty. But you might find something they built, and you can find that probably for thousands and thousands of years, whereas they were only around for maybe a few thousand years. Okay, right. So artifacts make sense. And having said that, I will stop these slides because I know it's putting everyone to sleep.
I think they're pretty cool.
Well,
Seth, we had a couple questions pop in. Is it possible that we are missing some of these signals because we're focusing on listening?
Well, I mean, what's the suggestion there? Should we broadcast? I mean, there are some people who like to broadcast. In fact, there's an organization called METI International, METI, not SETI. METI is Messaging Extraterrestrial Intelligence. In other words, broadcast and see if anybody responds. Mm-hmm. And that's actually headquartered by, their office is in downtown San Francisco.
We had Doug on our Cosmic Conversations not too long ago.
Okay, so there you go. Doug Vakoch is the guy. But the problem with messaging is, I think it's okay. Some people worry about it. They say, you message somebody and they'll say, hey, there are humans over there. Let's send our interstellar battle wagons in their direction and wipe them out. I mean, that's an expensive project for them.
We would have had to really tick somebody off somewhere.
That seems like an unnecessary worry. And besides, all the radars down at SFO are already broadcasting anyhow. So, it's silly to worry. But I think the real problem that you have with transmitting is only that if, say, you broadcast a signal to somebody who's 50 light years away of some star system, it takes 50 years for the signal to get there, and then they decide, okay, we'll answer these guys. And then it takes another 50 years for the response. So you have to be very patient.
And I don't think our species is too good at that. We can't wait 10 minutes for text messages. You can see a little bit of what we're sending out into space right here, some of the lights from planet Earth. But we're not going to hang around Earth too long. Seth, you wanted to tell us some facts about Mars, if I recall correctly.
Yeah, you see, this idea looking for artifacts actually is nothing new. I mean, Kepler, some people may remember Kepler, John Kepler, he used a telescope on the moon back when telescopes were the latest and greatest in technology. And he thought he saw cities and rivers and all sorts of stuff on the moon. Well, that turned out not to be true. But Mars has been, looked at for artifacts much more recently. A little over 100 years ago, Percival Lowell looked at Mars with his telescope. he didn't see it in the kind of detail you see here, I can tell you. But he thought he saw canals on Mars. Everybody knows about the canals on Mars. And, he even wrote books about how the Martians were, digging up their landscapes to make these canals for agricultural
assumptions
purposes.
There, for sure.
Well, yes, and he reasoned that. But you have to keep in mind, in the 19th century, canals were a big thing for Earthlings too. So, it wasn't unreasonable to think they were building irrigation canals. But this is a obviously more recent view of Mars, and you don't see the canals. I might point out that Lowell died in 1916. That isn't so long ago, right? I mean, you think it is, but it really isn't. I mean, it's on the order of 100 years. Yeah. And he still believed that there were canals on Mars. Now, the funny thing is that in a way, there are canals on Mars. Well, I mean, canals in the sense of big ditches. Josh is showing you the Mariner Valley, or Valles Marineris. And, from one end to the other is the distance between San Francisco and Washington. So it's a big deal. It'll be a big tourist attraction. And anybody who wants to speculate in, real estate, maybe that includes our president, I don't know. But if you want to speculate in real estate, Valles Marineris is the thing to buy, because a century from now, there may be organized tourist trips to the Mariner Valley. There it is. It's big. It's beautiful. But this is not what Percival Lowell saw. He didn't even see this. And it is big. It's 200 times the area of the Grand Canyon. So, but it's another example of looking for artifacts. If he had found canals, you wouldn't have to worry about radio broadcasts from Mars. I mean, that did it too. Okay.
Is there a preferred way to search for artifacts?
Yeah, well, good question. And the answer to your question is, we don't know the answer to your question. It's still unclear. That's one of the problems. If you say, we're going to look for ET by using, a search for signals, it's very clear what to do. You build some big receivers and, there are various technical aspects to doing that. But if you say, no, wait a minute, we're going to look for artifacts, then you have to sort of guess what to see. They've built maybe this or that, or a big Dyson sphere or something, or a ring city like we showed her a bit earlier, but you're just guessing. However, there is this. What you could do is just stay awake whenever you're observing the sky and see if there's anything odd going on. I mean, recently there was this whole business about Tabby star. This was a star that had been observed by the Kepler Space Telescope. Not by Kepler himself. He was underground at that point. But they looked at this star, and it dimmed in brightness by 22% one time, and then it dimmed a couple of more times. It continues to dim occasionally. And it's not because there's a planet going in front of it. That's not what's causing this. Well, what is causing this? And the people simply did not know. And it was suggested by Jason Wright, he's an astronomer at Penn State, that maybe it was some big construction, a Dyson sphere that was blocking the light. It turns out that that's probably not true, but just, being aware that this is a possibility is the answer to the question. What do you look for? You don't know what the really advanced societies have built any more than Neanderthals know what the soups in San Francisco are going to pay to have built. But if you look for something unusual, maybe you'll find it.
Something outside the normal, something that's probably not natural.
Yeah.
Okay, so we talked about checking out our asteroid belt. That would certainly block light from our sun in some directions, especially if you lined up with it just right. Would this be something similar to what we were expecting out there?
Well, I don't know. The asteroid belt, whenever you see it in the movies, these guys are flying through the asteroid belt and they're holding the joystick, I mean, it's really tough because you got to avoid all these asteroids. Yeah, it's like flying through a swarm of wasps or something. But if you actually go out to the asteroid belt this weekend, because you can't think of anything else to do, if you do, you'll see that the separation between the asteroids is more like 1 million miles. So, flying through them, maybe you'll see one asteroid. You probably won't even see one.
Right.
But here's the idea. These are ideas due to Freeman Dyson, famous British-American physicist. And he said, look, if you were a plant living on an asteroid, which, may surprise you. I mean, it's not impossible. There's water in asteroids and so forth and so on. But you need all the sunlight you can get to do your thing. as a plant. So maybe you develop these big petals that collect sunlight, and the petals are always aimed at the Earth. They sort of swing around, right, the way some plants on Earth do. And so if we would simply look at the asteroid belt in the direction opposite to the sun, we might see some bright dots there, the reflection from these plants. If somebody has, there was a suggestion by a Boston University astronomer years ago saying that maybe the aliens are here mining our asteroids, and they have big solar collectors out there to get the energy, and maybe we can see the reflection from those. So that's another way.
So any changes in light would indicate that kind of non-natural source. That's a great thing to look for, is anything that doesn't fit the pattern.
Exactly. In fact, there was a small group of astronomers, I think they're in Sweden, but in Scandinavia somewhere, and let's face it, Scandinavia all looks the same from the perspective of San Francisco. But, what they did is they took an old data set of astronomical photos, right? Pictures of the sky that had been made dozens of years ago. And then they compared them with photos of the sky made much more recently, right? To see if anything had changed. Right? Does a star disappear, or does a galaxy suddenly get faint, or something like that? Just looking for changes. Yeah, they found some too, by the way, but it's not clear that they're anything having to do with aliens.
Right, that'd be a big change. So we heard that in 1886, Heinrich Hertz sent the first transmissions that could send through space. Even now, how far would you say it's traveled if Heinrich Hertz's broadcast has traveled unimpeded through the vacuum of space?
Well, it's been 134 years.
134 light years sounds about right.
So 134 light years sounds about right. That's a pretty long distance, actually, 134 light years. As I say, if you go out 300 light years, there are a million star systems within that distance. Within 184 light years, that's maybe 2/3. So it's like 35%. So 350,000 star systems are within that distance. I mean, if you could do this. This is high school math, but the signals from Earth, even going back only to the Second World War, where you had high frequency signals, are washing over about 1 or 2 solar systems, new ones, every day. So that's the rate at which we're announcing, hi, here on Earth we've developed a radio.
Well, Mary, if you put our software on full screen for a second, I've flown us out to about where Heinrich's signals would have reached. And you can see all these dots, all these stars, are solar systems that we probably would have gotten to so far. We have to get significantly closer to be able to see where the majority of our radio signals would be. So Heinrich's would be something of a trailblazer, not where most of our radio sphere has reached. Right.
And the other point is, this is a technical point, but Hertz's transmissions, Hertz's transmitter consisted mostly of a spark gap. This was before the development of tubes and stuff like that. So it's just a spark gap, and it makes a radio signal you can hear, maybe across the room, but it's probably not going to go 184 light years with any strength to speak of. And it was also in general at low frequencies, which bounce off the ionosphere. Those are all things that you can berate your kid brother with. But yeah.
Okay, so you wanted to check out some of the gas mapping of our galaxy?
Yeah.
Let me see if I can pull that up for us. Okay, so we got kind of a subtle reddish color, but if I point us in the right direction, we can see some actually pretty bright stuff that comprises an infrared survey of our galaxy showing us warm gas regions.
Yeah. And you might say, so why are we showing this other than for your aesthetic delight? Well, the reason that we're doing this is because one thing you might look for, I'm going back to that earlier question, what to look for, something like a Dyson sphere. And for those who don't know what a Dyson sphere is, if you don't have one at home, right, if you haven't ordered one from Amazon, free shipping, the Dyson sphere was just another idea of Dyson's, that if you really want to solve the energy problem here on Earth, you just put a lot of, just construct a swarm of solar panels outside maybe the orbit of Mars or something, certainly outside the orbit of Earth, collect all that sunlight and beam it down to Earth. No emissions, no waste gases, no global warming, none of that, right? Well, we haven't done that so far. It's not in the budget, but
Sounds ambitious.
It's ambitious, but if we were 1,000 years more advanced, we might do that. And maybe the aliens have already done it. And the point is, the outside of that swarm is going to be at maybe room temperature, something that's just you can't collect all the energy. That's thermodynamics. So the outside glows in the infrared. So maybe all we have to do is look for funny infrared sources on the sky. But what Josh is showing you here indicates why that's so difficult. I mean, people have tried, but it's very difficult because there's infrared everywhere, because there's dust everywhere. And dust is a little bit warm, right? I mean, this is the dust like you have, embarrassingly in your dining room, right? There's all that dust. And it's not absolute zero in temperature. It's radiating a little bit in the infrared.
Well, working at home as much as I have, I've discovered a whole galaxy worth behind my monitors. But
look under the bed, the dust bunnies everywhere.
Okay, so looking at all these features, if we saw something that was glowing brightly in the infrared but didn't have as strong a visible light component, would that necessarily be aliens, or is there something natural that would glow brightly in infrared and not visible?
Well, the problem is there are natural things that glow in the infrared. That's the problem with this. This is a great approach, except that it's not a great approach because of all the natural infrared. As you see here, there's infrared glow just about everywhere you look because of the dust in the galaxy, and that dust is useful in doing things like making planets and so forth. But if you're looking for ET, just because you find an infrared source doesn't necessarily mean something. If you found one that was really very, very interesting, you could go to the radio telescopes and see if there was maybe, a signal coming from that direction. That would clinch the deal. And, you could book your flight to Stockholm to go collect your prize, because that would be, a big discovery.
For sure. So we've zoomed out quite a bit, and we're looking at our galaxy now. A question we often get is, well, what if there's aliens in other galaxies? And I wanted to run my normal response past you. It's like, that's probably true, but it's going to be really hard for us to talk to them.
Well, you don't need to be ashamed of that normal response, Josh, because that's absolutely true. I mean, it's like saying, well, if we don't find any animals in North America, maybe we could also look at South America. Well, you could. But if there are any animals anywhere, I mean, you should expect to find some on your own continent, right? So looking in other galaxies for things, I mean, people have done it. I've done it, actually. But, it's harder because the distances are so great that any sort of signal, anything that you look for, becomes harder to do. But zooming back here so we can see the Milky Way in a way you won't see it from, the Embarcadero because it's too much light. It is worthwhile because, one thing that really advanced aliens might think about, right? Think about what an advanced alien might be like. It probably is a machine. I don't know, that soft, squishy 3-pound brains may not be the future of intelligence here on Earth. Maybe we have thinking machines, but whatever. Is that they will realize by looking at this galaxy, our own or somebody else's. I mean, there are 2 trillion visible galaxies. They're flying apart. Everybody knows about the expansion of the universe, and particularly during the COVID shutdown, everybody's going to the fridge much more often. So the universe, even locally, is expanding. They will realize that the universe is eventually doomed. All the stars are going to burn out in another 10 trillion years, 100 trillion years, something like that. All these galaxies will become dark. Eventually, they'll all collapse into giant black holes. That's what the future of what you're looking at here is. And, the whole universe is going to get quiet, dark, and very cold. I mean, it still exists. It doesn't disappear. Sure. It didn't exist before the Big Bang, but it's going to continue existing forever. And, maybe if you're a really advanced intelligence, billions of years beyond where we are, maybe you worry about that, because that means eventually you're going to go away too. And maybe they do something to try and change the universe. That's very, very speculative. Maybe you could write a short story about it.
Sounds great. So we had a question come in from Jerome. What would be a natural source for the FRB fast radio bursts we've heard about in the news with those regular recurring patterns?
Yeah, Jeroen, that like my Netherlands or so. What indeed could the fast radio bursts be? Well, they were found, at a desk at West Virginia University, more than 10 years ago, I think.
The signals were coming from a desk in West Virginia?
No, actually, but the discovery was, it was data actually, I think, taken by the Parkes radio telescope in Australia. But, this guy was looking at those data and he found these fast radio bursts. Now, could they be aliens? Well, that's very unlikely because some come from, there's one that's found in our own galaxy, and there have been dozens and dozens found in other galaxies separated by, in many cases, billions of light years. So the idea that societies billions of light years apart are all doing the same thing, that's like expecting that you throw a party and everybody wears the exact same designer suit to that party. Not very likely unless you send out a memo. There's no way to send out a memo. So, they're not aliens, but what could they be? Well, if you know the answer to this, write it up this afternoon and send it to the Astrophysical Journal because it will be the paper of the year. Nobody knows for sure, but here's the problem with knowing what it is. There's a lot of energy involved, we think, because you can pick them up with an antenna in British Columbia, which is where a lot of them are being found these days. Mm-hmm. And you can pick them up with an antenna, and even if they're coming from 3 billion light years away, as one of them was, that means that's whatever it is that's making them has to be really, really energetic, has to be very powerful. And so how do you get that much energy, to be blasted, belched into space? You might have a couple of neutron stars collide. You might have some black holes collide. Have something big, really big, as William Shatner said. So it's got to be big. But on the other hand, we also know now of repeating fast radio bursts, right? Mm-hmm. And, so you suddenly see this squeak for a thousandth of a second or whatever, radio squeak. And then, hours later, maybe a week later, you get another one. And then you get another one. And in some cases, they're very rhythmic, which sounds like something in orbit. But that can't be colliding black hole.
Right. Those should only happen once.
It should only happen once. You can't back them up and say, oh, do that again, guys. So, it could be that there are two kinds of fast radio bursts, or that maybe all of them repeat, but you just have to, look at the ones that aren't repeating long enough to see the repeat. I mean, it's unclear. But here's my bet to everybody in the Bay Area. Within 2 years, we will have a good theory of what fast radio bursts are. And if not, I'll buy you a cup of Pete's.
Sounds good. We had somebody comment, maybe that's them calling right now.
Yeah, it could be. I don't know who it is, but it's probably the IRS again.
So we've got a bunch of questions popping in. I want to make sure that we give them some time. We had Nancy asking, do you take any interest in UFOs?
Well, I do, because every day I get emails from people who've seen things. And these are not crazy people. I mean, they've seen something. They occasionally send me photos and videos and so forth. And, I try and look at those. Photography is a long-standing hobby of mine. And as a consequence, very often I can recognize photographic effects that account for what they're seeing. But sometimes I can't. There have been these stories in the New York Times most visibly recently about this secret government project to look at these things in these funny videos that Navy fighter pilots have taken, showing this peanut-shaped thing and so forth and so on.
By San Diego, I think.
Down by San Diego, also on the East Coast. And I've written several articles about that. So I would suggest, if you have an interest, in my opinion of them, go to the SETI Institute website, SETI.org, and check out that article.
Okay.
I don't think they're aliens, by the way. I hope I won't disappoint anybody. Probably will.
Well, people often get their heart set on a specific kind of alien, too.
Maybe they're waiting to be abducted.
More questions popping in. Let's see what we got. I can see one. Would it be possible we aren't able to detect aliens because a technology mismatch is even with a similar advanced extraterrestrial?
Yeah, well, that's certainly possible. I mean, if you would talk to the scientists of 1860 or 50, make it 1850, and said, how can we find the aliens? They would have said, oh, well, what we should do is use our telescopes and look at Mars, right? See if we see anything. And they did do that. But you would say, in hindsight, you'd say, oh, that's pretty naive. And it could be that 150 years from now, people will say, oh, you guys were looking for radio signals. How naive of you. I mean, that could be. I could give you counter arguments to that, but let me not do that. It could be that we're using the wrong technique, but what do you do then? Do you say, okay, Bob, that's it? We're surely using the wrong technique. We have a technology mismatch, so we're just not going to look.
Right. Wait until we develop the technology we don't know about.
Right, exactly. And who knows when that's going to be, right? So I think it's better to use your shovel and dig in the sand here, because there may be some buried treasure that you come across rather than, just lying back and, reading a good book or a bad book.
I know my preference. Will the event of quantum computing help find alien signals or messages?
Well, quantum computing, it doesn't have to be quantum. It's certainly the case that the advent of faster computing, whether it's quantum computing or anything else, and certainly things like machine learning, which don't use quantum computing yet, does help. How does it help? Well, it burns up your budget. There's that. But how it actually helps is because if you're going to look for artifacts, you don't know exactly what to look for. Mm-hmm. But machine learning, for example, might say, wait a minute, this doesn't look like all the other parts of the sky look. You could have an experiment like that. It certainly helps with conventional SETI because, all SETI radio receivers have been built with kind of a hardware filter to look for narrowband components in the signal and say, okay, that's ET's signature. But again, if you have better computers, faster computers, you can use machine learning and say, look, we're just going to use a wide angle lens instead of a telephoto lens. Let's look at for different kinds of phenomena. So yes, it will help.
Are there any ways for lay people to help out? I know a lot of folks were fans of SETI at home.
Yes, SETI at home. Well, they put that on pause. That's a project at the University of California, Berkeley. Not because it isn't a good idea, but there's a certain cost to them to handle it. They have to maintain it. They have to feed it the data, and they just the real problem in SETI, and I know this is not interesting for most people, but the real problem in SETI is money. Mm-hmm. I got to say, this Earth here, Josh, has all the big cities for some reason in the northwest of Australia, where I can tell you, since I've been there, there's nothing much except flies.
We're showing you an infrared map. So if there's something hot or an oil derrick out there, they often glow brightly too.
No oil derricks that I know of. But in any case, clearly for anybody going to Australia in the next whenever, you want to go to this part of Australia, you will be
infrared out there.
You will be disappointed in what you find, but do it.
Not a bustling cosmopolis.
Yeah, well, it wasn't 10 years ago. But the bigger question is there any way you can help? There are a lot of citizen science projects for finding planets and other sorts of things that are more astronomy as opposed to SETI related. But again, that may be the way to find things. What is it? It's been like 5 years ago, and one of those citizen science projects was a Galaxy Zoo. I'm not quite sure, but a woman in the Netherlands, Henny, found something strange, and for a long time it was called Henny's voorwerp, which in Dutch just means Henny's object, and it turns out that it's a rather interesting galaxy. So probably not aliens, but an interesting galaxy. So bottom line, sure, get involved in some of these citizen science projects.
Question from Andy coming in. Hi, Andy. I've been dismayed by the notion of a Goldilocks zone and the possibility of finding life in the atmosphere of Venus. I've heard other folks suggest the ice layers of some of our moons. Is there a chance of the Goldilocks zone going away as a talking point?
Well, I don't know. I think from the standpoint of bear literature, I think a Goldilocks will always be a talking point. But you're right. I think that the questioner asks, poses an interesting query because, as we know, the Goldilocks zone, everybody knows what the Goldilocks zone, but in case you don't, it's where your soup isn't too hot or too cold. Or in the case of SETI, where your planet isn't too hot or too cold. If your planet is above 212 degrees Fahrenheit all the time, you don't have much liquid water around, it all boils away. If you're like Venus, it's 800 degrees. And it's hard to get much chemistry going, which is to say it's hard to get much life going. And if it's too cold, if it's like Pluto, it's frozen, all the time, then you can say, nothing's going to happen there either. But Pluto's a good counterexample. Underneath the surface of Pluto, there could be some liquid water, right? Because there's a little bit of activity, geologic activity on Pluto, apparently. And so that would warm things up a little bit. Or if you have a meteor that just crashes into Pluto, and, of course, you release a lot of heat when you hit a planet with a meteor, for those of you who've done it, and that melts the ice. And for a long time, tens of thousands, hundreds of thousands, maybe longer, years, it's locally quite warm. You have liquid water. So maybe things cook up there. And I think that the questioner's point that, well, why do we talk about habitable zones all the time? I think it's just that people are, they've got that into their head and they want to talk about it all the time.
I've been trying to put forward, instead of habitable zone, hospitable zone, where the hospitable zone is where it's very easy to have liquid water, but it's not by no means the only place where it can exist.
Yeah, that sounds like my Aunt Dorothy. It was always good to go to her place because she had lots of good snacks. So that was a hospitable zone.
A hospitable zone.
Hospitable.
Okay, I think we're running a little long on time, but I would like to take a moment to thank you, Seth. This has been an absolutely wonderful talk, and I know a subject a lot of people are really excited about. So if you folks have questions that you didn't get a chance to answer, please drop them in the comments. But Seth, once again, thank you for joining us.
It's been a pleasure, Josh. Can I ask one question before I go?
Absolutely.
If any of you give haircuts, send me an email.
We need a delivery barber service on the double.
It's
okay. Well, thank you
emergency.
so much. And with that, we'd like to thank all of our audience for tuning in from our page, from SETI's page, from SETI's YouTube. We really appreciate the support and the eyeballs. And from us to you, thank you for joining us. Please stay home. Please stay happy. Please stay healthy. We hope to see you all soon.